So in this session we're talking about differential amplifier AC analysis. In the previous session we talked about the DC analysis. Here you can see a differential amplifier having two transistors and supplied VCC and minus VEE across the collector side and emitter side. Similarly, two alternating current is or a voltage supply is applied it, and RS is very small, assumed to be very negligible amount of resistance. Similarly, we convert this transistor into T model so that analysis will be further easier. So this transistor having T model with IC current and RE emitter side resistance. So here you can see this T model is, the transistor is replaced with T model, and IC1 and IC2 are flowing toward the collector side. Similarly, we can represent this RE with thermal voltage and current across emitter side, which is DC current. So first of all, we write KVL across this closed loop, and this is V1 equals IB1 RS, IE1 RE, and IE1 plus I2, because these two current are added up to pass through this resistor RE. So in this way, but here we can convert this IV into IC upon beta, as we know, and this IC is almost equal to IE when the beta is very large. So in this way we can neglect this term if the multiple is RS, because this RS is very small as well as this beta is very large, so we can neglect this term. And if we neglect this term, we can get an expression having this only term. But we again can reduce this V2 by applying KVL in this loop in the same fashion, in the same manner. So in this way we can reduce two equations with two unknown, so we can solve them by substituting one term into another. Let's suppose we can substitute IE1 into this, and again next time we we obtain IE1 equations, and again IE1 value and IE2 value in this way. Similarly, VO equals V2O and V1O, you can see. In next video we will talk